going to start your class. My dear, this is one shot, right? Because someone study requested for chapter one, sir. Kindly arrange rapid revisions. So, my dear, this is a rapid revisions, or you can say one shot, right? Okay, fine. So, students, in today class, my dear, I'll just discuss and I'll give you short tricks, formulas of my dear. That is electric charges and fields. So without wasting students' time here, I'm going to start the class because this is a one-shot and rapid revision. So my dear kids, good morning, beta. How are you, SN? Okay. So students, first I'll discuss. Students already we have done, but just keep in your mind, students. Very good. But I'm happy, very happy to heard beta. Session. Now, students, first year, we'll discuss about property, property of charge. First, beta, we'll discuss about property of charge. Asan beta, call your friends quickly. Asan beta, call your friends quickly, beta. Okay. So, students, in property of charges, there already I see definition of charges: loss or gain of electron, or you can say deficiency of electron from one body to another body is known as charge, right? My dear, the next point here. Beta SI unit of charge. Keep not mind voids. Students, SI unit of charge. This is what, my dear? Coulomb. Second beta. What is Celsius unit of charge? Student, this is ESU. ESU stands for electrostats unit. Electrostat unit. Beta conversion applicable, my dear. Because you know SI to CGS. My dear, I hope all of you know conversion of units here, SI to CGS. So here beta again you can apply, my dear. That is 1 coulomb in SI. Students, 1 coulomb in SI, which is equals to students 3 into 10 to the power 9 beta G ESU. Beta keep in mind here, readily you will get beta anywhere. You can get at physics point only. Okay, fine. Now, students, I can say we have to discuss beta clear electrification. What, my dear? Electrification. Okay, what is electrification? As I said in classroom, my dear, process of charging is known as what, my dear? Electrification. Beta, we can charge body by different process. First, beta, I can say by friction. Beta, we can charge any body by friction. How, students? You can beta just simply check any. This is what you can say glass rod. Right, beta? And this is what you can say silk cloth. Now, students, if you will rub glass rod to silk cloth, so beta, what you can say, sir, glass rod will become positively charged. And my dear, your silk cloth becomes negatively charged. What's the logic, my dear? You can say here, beta, losses of electron, and here, bacha ji, you can say a gain of electron like that, beta. But this is a glass rod, beta. Keep note, my beta, X by Z. Beta, this is what you can say, student glass rod. Right. Beta, you can take another one, my dear. This is what, student? It's a ebonite rod. This is what, students? Ebonite rod. Right. Students, if we will rub ebonite rod to beta silk cloth. So beta, for this timing, what you can say, sir, ebonite rod will become negatively charged. And because he use silk cloth will become positively charged. Beta. So this is the beta conversion, my dear. Keep in your mind. Very good beta, yes, and beta, my dear. God bless you for your good job. Now, students, we can charge body by different method. This is what, students? By conduction. This is what, my dear? By conduction. Beta, here two body also beta in physical contact. Then you can say, hello beta X, hello beta X. Beta, this is what? By conduction. Beta, for friction, there is condition. Two body must should be in contact. Beta, first condition. Beta, for conduction, what you can say? Beta, let us suppose you have a positively uniformly charged conducting body, which is a sphere. My dear, you can say, beta, you have a positively charged, my dear, you have a positively charged conducting sphere, beta. Beta, another one in front of this, students, you have a neutral conductor, which is also a sphere. Beta, this is a neutral conductor, which is also sphere, my dear. Now we wanted to perform here. We wanted to let us suppose this is body A. You can call my dear XYZ name of the body A, and this is B. But I wanted to charge body B with body A. Beta, for these conditions, what is the things? Beta, you have to use what? Connecting wire. You have to connect body A to body B. Beta, once you will connect body A to body B, beta, you can find body B slowly starting charging. Slowly starting charging. Right? So this is body A and this is body B, my dear. Okay, beta, until I can say till what time, sir, body B will become charged. My dear, if potential will be not equal, body A and body B, till that time, you can tell, sir, body A and body B, they are transferring charge, body A to body B, because body A, my dear, at higher potential and body B is at lower potential. Beta, charge always, current always flow from higher potentials to lower potential. Right, my dear? Okay, third one here. But here I'm not explaining too much because already I explained. This is your rapid revision, but still I'm trying to connect the what is the core point of with a coming topic here. Last bitaji, this is what you can say by induction. Beta, superb important by induction. Okay. Beta, by induction, my dear, X, Y, Z, A, B, beta, I'll explain on next video. Take snapshot, beta. For rapid revisions, you have to must make notes with you. It's highly important for you, beta. Now, beta G. Now, here I'm going to explaining that is what, beta, charging body by induction. By beta G, what you can say induction. How beta G? Yes. Listen carefully, beta. You can understand here. My dear, here I'm considering here. Again, this is what uniformly charged conducting body. Beta. This is for students uniformly charged conducting body. Right? Okay. Now, beta, this uniformly charged conducting body, my dear, I'm going to place in front of neutral conducting body. Listen carefully, beta. Students, this is body A, which is uniformly charged. Now I placed in front of neutral conducting body. Beta, what is the meaning of neutral here? Write in chat box. What is the meaning of neutral? XYZ, beta, write in chat box. Meaning of neutral. Good noon, student. Good noon. How are you, beta? Neutral. Students, a number of number of electron is equals to, my dear, of number of electron is equals to number of proton. Beta, I'm very happy to hear, beta. Good. God bless you, beta. Now here. So, but I know this body remains neutral here. But you know, beta, body is neutral, true. But this body is what, beta, carry number of protons is equals to number of electron. So what you can say, my dear, sir, electron inside the body got attracted and started motion towards positively charged body. So finally, students, okay, yes, beta, how? But we just take, just it, beta. I'll check once. Give me a second. Now, SN beta, is it fine? SN beta, is it fine? Just write in chat box. Okay, good beta, SN beta. God bless you. So, my dear, this is a neutral body. So, neutral body beta containing number of electrons is equals to number of proton. Beta, I placed here positively charged body. So these all electron got attracted because of positive charge. And finally, students accumulated on the, you can say, left surface of a sphere, which is negatively charged. Now, students, because this part here, deficiency of an, beta, I can say a proton, but a deficiency of an electron here. Due to this beta, I can say this side of body will become positively charged. So this is B beta. You can write, uh, Mataji, good noon. How are you? Very happy to hear beta. So beta, neutral body here. So you can say, student, this is the way we can charge the body. But beta, keep in your mind, beta, in induction process, net charge will be zero. Why? Because no body remains initially what? In a neutral equilibrium. Body beta is in good noon beta, good noon. In a neutral equilibrium, my dear, right? Beta, one formula, just keep in your mind. Sir, anyone, beta, they can ask you, sir, you said body will become charged. True. Again, you are telling, sir, body, there is no net charge. True. But, sir, I'm asking you, what is the induced charge? Because body finally charged, na, yaar. So, you can say, what is the, beta, the induced charge? What is the induced charge? Okay, beta, which is equals to beta, you can say minus q, beta, it's a initial charge, minus q beta g. I'll write here little more big, minus q beta, 1 minus 1 by k. Beta, 1 minus 1 by k. The students, you know, k is what beta? K, I hope all of you remember here. K is, students, dielectric constant. K students, dielectric constants. Tell me everyone, what is the dielectric constant for beta G conductor? Tell me everyone, write in chat box. I taught you everyone as X, Y, Z, A, B, Mata Ji. Everyone just tell me what is the dielectric constant for conductor? I taught you in the classroom. Quickly, fast. Quickly, fast. Sortify. Beta, good noon. Answer me, boys and girls. What is value of K for conductor? I'm writing beta G. Conductor K bacha infinite. I taught you XYZ AB. Huh? Mataji. So beta, what is induced charge here? So finally, beta, I can write induced charge, which is equals to beta minus q here, because something by infinite beta goes to zero here. So this is answer beta. I can report answers to anyone. What is induced charge on a body B? So beta, as I taught you, what is the electrification? We can charge body by three different method. First is the friction. Second beta G, conduction, and third is what? Induction here. Now, students, I'm going to tell you basic points here, which is students. Now, just we are revising property of charges. Keep in your mind, students. This is what quantization, beta. Quantization of charges. What is my dear quantization of charges? Anyone from all of you tell me? Beta, body air, neutral. Body B beta G, neutral. Let us suppose you carried out here from here 10 electron. Right. What's charge over here, Mitchell? This is what positive here because B carried out 10 electron from body A. Initially, body A is neutral. Now, beta, you can give here this electron to this body. Right. My dear, but let us suppose I wanted to take, I can say out from this body here, 0.5 electron. Beta, is this possible? No, sir, this is not possible. Why not possible here, dear? Because all of you know, my dear, this is what? Electron is smallest unit of charge, which is not divisible, which is not divisible, my dear. Right? Okay. So, students, what is the result here? You can keep in your mind. Q, which is equals to, my dear, plus minus Ne. Q is equals to, my dear, plus minus Ne, where N is what, beta G, XYZ, Mata G? N is an integer. N is an integer. My dear, integer may be positive, beta. Integer may be negative, but never in fraction. But never in fraction. Very good, Mataji. But never in fraction. Okay, bacha. So one more beta last topic, which is a part of, I can say, quantization of charge, my dear. Take a snapshot here. Pause the video and you can better take snapshot. Now, students, this is last point for property of charge, which is, my dear, relativity theory of mass. Relativity theory of mass. Beta, relativity theory of mass, right? Okay. Beta, there is a formula here. You can keep in your mind. M is equals to M naught beta G 1 minus V square by C square. Beta, here you can write M naught is what, my dear? M naught, which is equals to raised mass. Beta, V is equals to speed of particle. C is beta G, speed of light. I hope beta, all of you remember. Beta, in normal life here, in general, beta, we are considering M is equals to M naught. There is no effect on mass. But keep in your mind, students, if V and C will become significant. Beta ji, for those case, you can't say M is equals to M naught. M naught equals to M naught. So what is the result, beta, which you can keep in your mind? Beta, don't be a spam. Beta, everyone, X, Y, Z, A, B, beta, be concentrate on lecture. This is request done from your side, beta. Your friends requested me, sir, please arrange one rapid revision of chapter 1 so that you can write comfortably at tomorrow exam. So, beta, listen here, bacha. Be concentrate. Don't be a spam, my dear. All of you, very good, beta ji. You have very good potential. You can qualify NEET, advanced, main, JEE, bacha. Beta, be concentrate on study, my dear. Don't bother, beta. Don't close, beta, more of anyone, my dear.
What is the property here? Boys and girls, beta listen carefully. Relativity theory of mass. My dear students, mass depends on mass depends on beta mass depends on speed of particle, but charge independent on, my dear, speed of particle. Beta, keep in your mind, my dear. Yes, I'll tell beta everything. I'll tell, my dear. Be beta in the class here. I'll do everything complete, bacha. Now, beta, we finished one topic here, that is property of charge. Now, my dear, I'm going to start, beta, electrostatics here. That is, beta ji, Coulomb's law. This is what, beta ji? Coulomb's law here. Okay, so beta, what is Coulomb's law here? It's very simple, bacha. I'll not go in much depth. Beta, like charges, if we have a 2 point charges, both are separated beta, distance r. You can see, sir, here you can write force on 2 due to 1 meter, like charges repel each other, my dear. Beta g force on 1 due to 2, you can write, sir, magnitude of force 2 due to 1 is equals to beta 1 due to 2. Beta g, direction opposite to each other. You can see beta electrostatics force is an action reaction pair. So finally you can write beta g. And one more thing, beta, you can also say electrostatics force is an action reaction pair, and it always acts line joined between two charges. Due to this, my dear, you can also say electrostatics force is an central force. Beta, keep in your mind, this is a theory question they can ask. Electrostatics force is an beta central force here. So you can write beta g force. I'm telling here F on 2 due to 1 and 1 due to 2. Let us say F beta. Force is directly proportional to magnitude of charges, my dear. This is what? Q1 and Q2 beta, right? Either beta you will increase or decrease magnitude of any of the charges, my dear. Force will increase or decrease. It will totally depends, beta J, what we are doing. If we are increasing here any of the charges, beta, force will increase in multiple. Beta, any of the charges, if you are decreasing, my dear, then you can say force will be decrease in multiple. Now, beta, another one more I can see, beta. You can take this all are beta. I can say practical aspect. Electrostatic force, beta, is obeying the rule of what? Square of distance between two charged particle. Beta, it will decrease the separation between charged particles, so force will increase. Students, it will increase the r beta, force will be decrease here. Right. I know if just my dear, remove this proportional sign and use beta ji some proportional constants. You can write beta F is equals to K Q1 Q2 by R square beta. Keep in mind here, where K is what, my dear? K is proportional beta ji constant. Right, you can write with as k is equals to 9 into 10 to the power 9. Beta, just keep in your mind, these all things beta highly important. Beta Coulomb square. K beta you can also write here, which is equals to 1 by 4 pi epsilon net. So you can write with as epsilon net is equals to 1 by 4 pi k, which is equals to, my dear, 8.85 10 to the power minus 12 beta. This is what beta, just unit reverse here, Coulomb square, Newton meter square. Coulomb square beta is what you can say Newton meter square. So these all point beta which you can keep your mind will help you a lot in all the questions, my dear. Okay, fine. So this is about key bacha. There's something here which I wanted to discuss because time is very less. So here beta, I'm going to discuss here next concept. That is what, my dear? Coulomb's Coulomb's law in beta G media. Right, my dear? Okay, so here beta, I'm just considering, my dear, pair of charged particle. Both are identical in nature. I mean to say both are positive, my dear. Here, students, I'm calling air. This is what? Beta G air. This is what, my dear? Medium. Air beta, you can say here. This is, we have a charged particle Q1 and Q2. Beta here again, my dear, charged particle Q1. This is Q2. Beta separation remains R. Separation remains R. Beta, here I wanted to write a expression of force. You can see F is equals to K beta G, Q1, Q2 by R square. K beta, what is the real formula of K beta? K, students, 1 by 4 pi epsilon naught into epsilon R. Beta, this is the real formula here. K beta G, 1 by 4 pi epsilon naught bacha and epsilon R, right? Okay, my dear. So, for air beta, for air beta, you can see our epsilon R is equals to 1. So K, student, for air case, you can write 1 by 4 pi epsilon naught bacha party. So simply I write beta force 1 by 4 by epsilon naught Q1 Q2 by beta G R square. Okay, beta, let me talk about here, my dear. So here you can say again beta, that is force, which is equals to beta K prime beta, because this is different K. Q1 beta G, this is Q2 by beta, you can say R square. But let me discuss about beta K prime. So beta, this is a real formula of beta. You can say K prime 1 by 4 pi epsilon naught into epsilon r beta. So you can write here force is equals to this is beta force in a medium. This is beta force in a vacuum or air, my dear. You can see, student, this is 1 by 4 pi epsilon naught epsilon r Q1 Q2 by R square. So finally, beta, you can write here as a result, keep in mind FV by FM, which is equals to beta epsilon R. Beta, let me clear you beta one question here. What is this? Beta, this is a very good question. Beta, let us suppose this is beta, we have a charged particle. Beta, it's the example beta, come I can say concept. Beta, this is Q1 charged particle, this is Q2. But I can take care. One is positive, one is negative. Right, my dear? What you can see, student, so there is what? Q1 is what? Attracting to Q2, and Q2 is what? Attracting to Q1, because both are what? Unlike charges, my dear. Now, beta, I'm going to place here another charge particle, which is Q3, but this is also beta, negative only. So you can see, bacha, sir, Q1 need force on Q1 will become more, right? Beta, this is the concept here, which is asked in beta, I can say JEE, beta maybe 2003. I'm not pretty sure, but JEE ask here. Beta, what is the concept here which you can keep in your mind? Force between two charged particle independent of, beta, I didn't tell this point in classroom here, so I'm telling my dear here only because just now I click in my mind. My dear, force between two charged particle which is independent on presence or absence of other charges. Beta, force between two charge particle will not depends on is there any third charge particle present or not. Right. So this is a point beta which you can keep in your mind. Uh, what was the force is independent of presence or absence of other charges. Right. The next questions here. Let us suppose now beta I'm considering pair of charge particle. This is I can say demand by Mataji. Q1 beta G, this is Q2 beta which is in air. Now beta same pair of charge particle beta I'm going to place in medium. Right. Now what is the question here? Comment on beta charges remains same. You can see my dear, this is Q1 and this is Q2. Comment on interaction force between two charge particle. One is in air and one is in medium. Comment on interaction force between two charge particle. What is your answer, my dear? I want it. My dear, be concentrated. I don't know here. Q1, Q2, Q1 and Q2 beta. So this is in air, this is in medium. Beta, what is it? Beta, this question also beta asked. I can say beta pattern of this question is not exactly this beta, something different. JEE, my dear, advanced 2020. Beta, no change. Beta G, no change. Beta, interaction force will become beta, remains constant. No change in force. My dear, force will become constant. My dear, force will become constant here. So students here you can write here no change in force. So this is but a very crucial condition here. Be alert during writing the paper in the examination hall. Either force, either pair of charged particle placed in air or in medium, interaction force will remain the same. What will be changed? F net will be changed, beta. F net will be changed. So, my dear, keep in your mind. This is a very good question here. Now, beta, have a look at next questions, my dear. Okay, beta, you can say this is body A, beta, which is isolated, which is, my dear, isolated, right? What is the meaning of isolated, Macha? Repulsion. You correct, my dear. You correct, my dear. Isolated here. What implies isolated? Beta, isolated implies you can't take in terms of energy, you can talk in terms of beta heat, you can talk. You can't take and can't give energy to a system. You can take beta. This is body A, which is inside isolated body. This is body B. This is body C. Body A beta is 12 coulomb. Body C beta is 15 coulomb. And body C beta is minus 2 coulomb. Beta, due to some, you can say, rearrangement of charges. Uh, Beta X, good beta. Beta, this is now beta due to rearrangement of charges for this body. Beta, you have to comment on charge of body C. How much? After beta rearrangement of charges of body A, beta this one also my dear isolated. This is body A, body B, and this is what my dear body C. Beta ji body A there is I can say beta ji 10 electron. But everywhere here charges electron only, right? Not coulomb. This is 5 electron. Beta find charge on body C. Coulomb you can take beta. Find charge on body C. Tell me fast. Answer please. Anyone from all of you? Those watching the video live session. Better write your answer. What is the question? My dear, this is isolated body A. Charges body A 12 coulomb. Body B 15 coulomb. Body C minus 2 coulomb. Due to rearrangement of fashion of charges of body A, beta charges got changed. Now, beta, body A is 10 coulomb, body B is 5 coulomb. You have to find charge on body C. Okay, you answered. Very good, very good. Algebra, bacha. You know, yeah, this is isolated system here. So, students, in solution, you can write, my dear. You can write, my dear. That is what? Charge initial is equals to beta G charge final year. So beta this is what? Initially beta 12 plus 15 minus 2 is equals to 10 plus 5. I don't know your x. So you can beta take your any value x. Right. You can see beta 10 plus 5 beta. So this is happy body. X beta 10 coulomb here, my dear. Someone answered me 15 beta. This is wrong beta. Coulomb beta, not electron here. 15 coulomb. It's a 10 electron with charge. Answer student that is 10 coulomb. Answer my dear 10 coulomb here. Okay, fine. Now let's have a look here because we are discussing my dear basically numerical based on this here. So come to the point. Beta mostly I be remember everyone. These questions here. Beta I can say have identical beta in these questions here. I'll discuss pendulum concept first. Students, pendulum concept. Yes, beta. This is pendulum concept, my dear. You can say beta charge q mass m, my dear. Charge q mass m. Beta this angle is what? You can say beta g theta. This is what? Theta. L beta is length of a string. Beta for these conditions, beta we have to find main thing here, tension in the string, what is the forces and all. Beta will go one by one. Students, as I taught you, tension is always acting along the string. So this is a theta, my dear. You can say this is remains theta. This is t beta. You can say, my dear, this is t cos theta. This is, you can tell beta t sin theta. Beta due to mgr, there is a gravitational force, my dear. Hare Krishna, my dear. Now, beta ji, next year, you can say beta ji, this is Fe. Simply beta, just equate all the forces here. You can write, my dear, for beta vertical equilibrium. No beta, what is the meaning of equilibrium here? You can simply say, my dear, sir, net force in that particular direction is equals to 0. Right? Jai Sri Sama, student. Net force beta in that particular direction which is equals to, my dear, 0. Right? So we can say beta ji, this is t cos theta which is equals to beta ji mg. Let us say beta this is vertical direction here. So t cos theta beta minus mg equal 0 beta remains same here. Equation number 1, my dear. Now beta I'm just talking about here for horizontal students equilibrium. But again you can write here t sin theta which is equals to, my dear, Fe. Very good beta, need 40. Very good. God bless you beta. God bless you beta ji. This is what, students, t sin theta which is equals to Fe. Beta this divide beta the equations number second by first. So students, you can say tan theta which is equals to beta g Fe by mg. This is what beta you can say Fe by mg beta. This is a conditional here. Okay. So beta we can ask multiple things. You have to find tensions. The one thing here I wanted to clarify what is Fe. Fe beta, I hope all of you remember here. This is a point charges K Q1 Q2 by beta. You can see R square. What is R here? You know everyone. R is what separation between charge particle. Right, my dear. Very good. Now this is L bacha. I'll take beta one more time component, my dear. X, Y, Z, A, B beta, Mataji. Okay, beta, this is the condition, students. You know, L is the length here. So we can say beta, this is theta. You can write, my dear, this is what remains theta. L beta, you can treat as a displacement vector, my dear. So this is, students, you can write L cos theta beta, and this is what you can write L sin theta. So my dear, this must length beta how much? L sin theta beta, and this must length how much? L sin theta. So what is R, students? You can write R is equals to L sin theta, student. So you can write finally Fa is equals to beta K Q1 Q2 y beta 2L sin theta, my dear, whole square. So this is all about, my dear, I can say component, I can say the concept on pendulum. Now beta, I'll do few questions here so that you can feel comfortable. But I take snapshot here, make short notes beta. It's highly appreciable beta. It will help you a lot, my dear. Okay. Now beta, have a look of the questions here. Beta, find following. Beta, first Students, you need to find tension in the string. Second beta electrostatic force. Beta these two things beta you have to find. Remaining beta data here I'm going to swing here in the diagram itself. Beta this is a 10 coulomb. My dear, this is also 10 coulomb. Mass beta z I'm considering here 10 gram. I'm writing beta here. Mass is equals to beta 10 gram. Beta q1 is equals to q2, which is equals to beta 10 coulomb. Beta angle making by the string from vertical, my dear, this is what 37 degree. This is what remains beta is 37 degree. Beta we have to find beta these all things, right? Student, just try. I'm giving you 20 seconds. Everyone, boys and girls, try these questions. Yes, beta. Try everyone these questions here and answer me quickly, beta. Everyone, answer me quickly. Okay. Now, my dear, I'm doing here. You can do beta. Pause the screen here and try yourself. Once you will finish beta, then you can watch my solution. Now, my dear, have a look of the solutions here. But as usual, my dear, first I'll take component of tension force, which is T. This is beta 37 here. So you can freely say, so this is also 37 beta T here. So you can say this is what, my dear, T cos 37 degree. This is what, my dear, T sine 37 degree. Due to beta mass here, due to Earth gravitational pull, mg acting in downward direction, like charges beta, so you can say Fe is what? Away. Beta, this is things which you must shown in the diagram. Now, students simply can write over here beta from ABD, that is what, my dear? Sir, T cos 37, which is equals to mg for vertical equilibrium. Beta, we are interested to find tension here, so you can easily write which party. This is what, tell me everyone. Sir, T cos 37 is equals to mg here. I'm just rewriting again. We are interested to find tension, students. You can write mg by cos of beta 37. Beta, again I'm telling you, empty triangle, magic triangle. We remember every boys and girls, those who are watching me pan India. Now, students, this is 3, this is 4, this is 5. Beta, this angle you can write beta 37 degree. This is, my dear, you can write 53 degree, right? Okay, so beta from triangle you can say cos 37, which is equals to 4 by 5 mg beta here. This is in 10 gram beta. You need to convert in kilogram. So 10 into beta 10 to the power minus 3. It's a kilogram here. Multiply by 10 because mg beta it's mass. G multiply by g beta. My dear, here I considered g is equals to 10 meter per second square. Beta, it's your convenient here and totally depends on instruction of questions. If they will mention, then you can take g is equals to 10 meter per second square. If not mentioned, then you can take beta, that is g is equals to 9.8 meter per second square. My dear boys and girls, look at here only. Cos 37 here, you can write from triangle beta. This is what 4 into 5 beta g. This is what you can say are 100 beta g. T is equals to 100 by 4 into 5 into 10 to the power minus 3 beta. 425 is 100 here. So 25 beta 5. This is what you can say 125 10 to the power minus 3 Newton. 10 to the power minus 3 beta. This is your first option here for tension. You can write 0.125 Newton. You can write what's as 0.125 Newton. Okay, my dear. Now here I'm going to find that is Fe. So this is what beta? Fe in second part. Fe, you can write Fa is equals to K Q1 Q2 by R square. It already are I shown in the theory part. R is equals to beta. R is equals to 12 sine theta. Here, bacha, I'm considering my dear L L, which is equals to beta g 1 meter. L is equals to beta g 1 meter. So now beta, I'm going to find here basically my dear Fe, which is K Q square by beta g R whole square. K equal to 9 into 10 to the power 9, as I taught you. Q square beta, Q already know, which is equals to beta g 10 coulomb. So you can say, my dear, this is 10 whole square beta. And R is what? 12 sine theta, L beta 1 only. You can say 2 sine 37-degree beta whole square. So Fe beta, you can write 9 into 10 to the power 9 into beta g 100. 2 2 ja 4 into 3 3 ja 9 by 25. So you can say this 9 beta, this 9 here, happy birthday. Beta this, yeah, I can say 25 times, beta this will go up here. So 25 into 25 beta, what you can say 625. So students, Fe is equals to 625 10 to the power 9 Newton. So beta, this is the only part of calculation beta. So be remember here, be very motivated beta for during solution of the questions here. So beta, successfully I completed their Coulomb's law in a medium with numerical, right? Now which I'm going to just solve here one numerical, which is very yes beta, very good beta. God bless you. You are in live son bacha and you are answering the question. It's a proud moment for me. Yes beta, it's a proud moment for me, my dear. Stay blessed beta, stay calm, and beta, gain your mission here, achieve your mission. Now students, this is a very easy and simple question, students. My dear, here I'm considering an equilateral triangle. My dear, here I'm considering here an equilateral triangle, which is q q q. Beta, you need to find beta, find f net at any corner. My dear, find find f net at any corner. Yes, beta. So unequilateral triangle here, so you can see the side must should be balanced, which is equals to A. Beta, I'm writing here. So let us suppose, my dear, for my own convenience, I'm calling this is 1, 2, and 3 beta. You can say this is beta force on beta 1 due to 2 beta in this direction here. You can say force on 1 due to 3. Basically, we wanted to find net force. So beta, what you can say, sir, we have to apply beta parallelogram lawyer. Beta, this angle is what? 60, because I hope all of you remember here. Beta, this angle is 60 here. So again, you can say this is what beta g 60 only. Beta, for getting here, I wanted net force due to these two pair of charges beta. So I'm going to use beta parallelogram law of vector additions of two vectors quantity formula here, which is what beta? I can write once formula f net, which is equals to beta g. Let us suppose here I'm calling beta f1 due to 2 is equals to f1, f1 due to 3 beta g f2, right? And beta, in fact, here I wanted to find f1 2 and f1 due to 3. What is the magnitude, my dear? Right, f1 2 beta g and f1 due to 3, which is equals to kq square by beta g a square. So you can say beta g, this is a square plus beta g. You can say beta a square plus b square plus 2ab cos theta beta. So you can say, sir, all fr remains same, sir. So you can say beta f square plus f square plus beta. 2f square cos of 60 degree. My dear, you can tell sir cos 60 which is equals to 1 by 2. Cos 60 beta 2 finish here. So you can write f square plus f square plus f square which is equals to my dear 3 beta g f square. I can take you can write my dear for further step. So this is root 3f and f is what my dear? Already I calculated here my dear. So this is root 3 kq square by a square. So beta it's very repeated questions my dear. Very beta God bless you my dear. God bless you beta. I don't know what is your name and from where are you watching, but your response is very good here in live session. Yes, I can tell you beta. You're very good candidate here. Beta, stay motivated towards your mission beta. God bless you all. Beta, for you beta. Literally I'm feeling a very good candidate you are. Yes, no doubt. No doubt, beta. Okay, my dear, put the heading here. Problem based on series. My dear, problem based on series. Beta, this is the first questions. What is question here? But I'm writing first time questions here. Questions remains in forever. Find out F net charge placed at origin beta. This is the questions here. Now students, I'm calling here. This is my dear 1 coulomb beta. This is 1 meter, 1 coulomb beta z. This is 2 meter beta z, 8 coulomb. It has a 3 meter, 27 coulomb. Up to beta, this is 10 meter, yeah, and this is 1000 coulomb, right, beta? Listen carefully, beta. How now I'm going to solve the questions here. Beta, this is a very common format, my dear. So just keep in your mind here. Here I'm trying to connect here everything. I don't want to skip anything with you. But I know what is the question here. Beta, we have to find F net charge list at origin. So beta, always you can take care this charge as a Q1. So the first pair beta you can write here like this. This is 1 coulomb. Beta, this is first pair. Second pair beta is 1 coulomb remains same beta. This is my dear 8 coulomb. Third beta is 1 coulomb and beta is 27 coulomb beta. 1 7 year and 27 coulomb and beta is so on. So you know beta separation is what my dear here. This is 1 meter my dear. This is beta is 2 meter. This is my dear 3 meter. So here I wanted to write my dear, this is F net. This is my dear F net. Beta, I'll say my dear, this is pair number 1. So I'm calling beta, this is F1. My dear, I'm calling here, this is F2, beta pair number 2. Students, I'm calling this is what F3. F1 beta, you can simply say sir K into 1 into 1 upon sir 1 whole square. You correct beta. Now you can say K into 1 into students. You can write 8 upon beta 2 whole square plus beta z K into 1 into beta z 27 upon beta 3 whole square and beta so on. Finally, you can see sir K's are available everywhere. So we can write my dear K common here 1 plus beta. This is 8 by 4 plus beta z 27 by beta z 9 and beta g so on. So finally you can write beta. This is K 1. There is no change. 4 to the 8 beta 9 3 is 27 beta. You can see this is what up to n here. Beta, this is basically formula beta g. 1 plus 2 plus 3 plus 4 and beta n here, which is equals to my dear n into n plus 1 n into n plus 1 by 2 beta. So beta for this entire terms my dear, I'll replace to this formula. So students, you can write finally f net, which is equals to k into n into beta n plus 1 by 2. N is what, my dear? Up to 10 here. So you can replace beta here. N is equals to 10 beta g. So finally you will get f net beta z k into 10 into 10 plus 1 by 2 beta. 2 5s are 10. So answer you can write 55k. Anyone answer these questions? Okay, sir, we would not take 1 coulomb to 1000 coulomb. Yes. Why, beta? Mataji, uh, I don't know, beta, who is, but I can say Malaka. My Malaka, beta, you take, beta. Listen, beta, carefully. My dear, this is the initial charge. But I know Coulomb's law, beta, applicable for pair of charge particle. Beta conditions na point charge. So you can take, my dear, this is what beta g 1 coulomb is the first point charge, 1 coulomb beta second point charge, one pair beta completed, my dear, right? Next pair beta you can say 1 coulomb and then beta g 8 coulomb beta, right? This is pair number 2. Then beta g 1 coulomb beta g, this is 27 coulomb, pair number 3. Then beta g 1 coulomb and beta 64 coulomb here, pair number 4. Beta like that, yeah, just beta we can make 1 1 1. So 1 beta always you can take here q1 for making pair of every pair. So you should beta, you should take beta 1 coulomb and beta 10,000 coulomb here, beta that is pair number 10. So beta finally here just you can see that we are getting general terms. So beta you can apply this general formula bachas and you can solve this question further. I hope you got it. I hope you got it, my dear. uh Now beta ji, I'm going to just solve beta next questions. Questions remain same, bacha. Find f net beta charge placed at origin. Beta listen carefully, my dear. Beta this is remains 1 coulomb. Beta this is 1 meter, 1 coulomb. Beta 2 meter, 16 coulomb. Beta 3 meter, 81 coulomb. And beta up to here, this is 10 meter, beta 10,000 coulomb. Yeah. Questions remain same, bacha ji. We have to find beta f net. So students, for solution, again beta you can take care pair like this, 1 coulomb and 1 coulomb beta. So I'm writing directly here one only, 1 beta into 16, my dear, plus k into 1 into 16 upon beta z 2 whole square, because for 16 beta from here to here distance is 2 meter. Next students, k into 1 into beta 81 upon beta g, you can say 3 whole square and beta g so on. You can take beta f, means k beta common from everywhere, my dear. K into 1 plus beta 16 by 4 beta, it's 2 square 4 plus beta z 81 beta 3 square, this is 9 and beta so on. You can say beta sir 4 4s are 16, 9 9s are 81. So f net, my dear, you can write over here k into 1 plus beta 1 square 2 square 3 square and beta z n square. So beta this is a series, my dear, 1 square 2 square 3 square n square, which is equals to n into n plus 1 into 2n plus 1 by beta z 6. Yes, beta I'll replace all these entire terms is equals to this beta. So finally beta z f net you can write k into n plus 1 into beta 2n plus 1 by 6. Now students you can replace here and is equals to 10. So beta f net you will get k into 10 into beta 11 into beta 21 upon beta is 10 here. So you can see sir, this 10, sorry, my bad beta, it's a 6 only here. So you can say beta 2 3 are 6, 2 5 are 10, 3 7 are 21. How much coming here? 7 5 are 35. 35 into 11, how much coming here? 365. 35 into 11 is a day. What can you say here? Anyone from all of you tell me? Beta G, 35 into 11 here into K. How much? 35 10 are 350. 350 plus 35. 385 na yaar. You can say bacha. This is 385K. 385K. Half. Okay. My bad. Extremely sorry, my dear. Extremely sorry, ma'am. How to take FNet. Okay. I'll tell. Listen carefully, beta. Listen carefully, my dear. I'll tell bacha. Learning candidate are most welcome here. I'll go slow. Don't worry. My dear, listen carefully. Beta, FNet na writing. Not a big deal. It's very easy, beta. I don't want another rough paper. I'll I'll make beta rough paper. Give me seconds. Hmm. Yes, beta. Listen. Listen carefully, beta ji. How this is. Beta, first I'll make diagram. Ah, where it is. Hmm. Come, beta. Maybe this is not visible for you. Beta, this is one coulomb which is placed at center or origin beta. This is beta 1 meter, 1 coulomb. Beta 2 meter, 2 coulomb. Beta G 3 meter, 81 coulomb. Beta G 10 meter, 10,000 coulomb. Beta very simple here. First beta F1 I'll write. Beta this is 1 coulomb and beta 1 coulomb. Beta. These two pair, my dear. Beta this is F1. Right beta? Okay. Then beta G 1 coulomb and 2 coulomb beta G. 1 coulomb and beta G 2 coulomb beta. Second pair beta. Beta this is 1 coulomb and 2 coulomb beta. Second pair. Third beta G you can say this is 1 coulomb and beta G 81 and beta and so on. Right, my dear? Okay. This is you can write beta Z. This is 1 meter. This is beta Z 2 meter. This is beta Z 3 meter. Don't worry, beta. You can ask here. I'll guide you, my dear. Beta, we wanted FNet here. Beta, we wanted FNet here. So we can say beta, this is the first pair here. So we can write, my dear, this is F1. My dear, this is what? Pair number 2. Beta ji, this is F2. This is beta, you can say pair number 3, which is F3, my dear. Keep in your mind, beta. Okay. Students, I'll write here. This is first F1. Then beta ji, F2. Then beta ji, F3. Then beta ji, I can say, and so on. Right. F1 beta formula I can apply with K Q1 Q2 by R square. So 1 into 1 beta remains 1 year, 1 whole square beta remains 1 year. So no need to write anything. Plus beta G, F2 year. 1 coulomb into 2 coulomb beta. You could write beta G, K Q1 Q2 by beta whole square. Right, bacha? Okay. This is 2 coulomb beta. This is 16 coulomb here. 16 coulomb beta. So beta 16 coulomb here. So K beta 1 into beta. This is what you can say 16. But I can correct me here anywhere if I'm wrong. Now students, you can say K into 1 into beta 81 upon beta G 3 3 is 9 and my dear so on. Right. Finally beta you can write here this is remains K beta plus beta K into 16 upon 4 plus K into 81 upon 9 and so on. 9 9 ja beta 81. 4 4 ja 16. So k plus 4k plus 9k and so on. Right, my dear? Okay. Students, you can write further here. Bacha ji. Beta, I can make a square, bacha. 1 square, 4 beta g square, 2 square, 3 square beta g, 9 and beta n square. If beta you're getting here this kind of series, so beta you can remember here, you can recall. This is what beta formula here, n into n plus 1 into beta 2n plus 1 by 6. Finally, beta, you can write here this entire terms beta I can replace with this formula. And my dear, you can take n is equals to 10 beta, up to 10 meter beta. We have to calculate, my dear. So n is equals to 10 beta. You can fit beta n over here. Yeah. N is equals to 10 n plus 1 beta. This is what 11 2n plus 1 here 21 by beta 6 here. So beta I can solve here and you will get this is 385k. I hope you got it. But really, if you got it here, beta, write in chat box. Write in chat box, beta. Your opinion. Your opinion matters, my dear. Your opinions matters, my dear. Your opinion matters, my dear. Okay, fine. I hope you got it. M by SG. Okay. Bacha ji, next question, sir. My dear, questions remain same. Find F net charge placed at origin. Right, beta? Okay. So here is students, you can go through this. Beta, this is 1 coulomb. Beta, this is 1 meter, 1 coulomb. Beta, this is 2 meter beta. 2 2 ja 4 2 ja 8 2 ja 16 2 ja 32. Beta, this is 32 coulomb. And beta, this is up to beta. You can say this is 10 meter. And this is beta 1 lakh coulomb here. Questions remain same beta ji. We have to find, my dear, we have to find F net beta, right? So how can we do beta ji? This is remain same beta formula. You can use F net is equals to, but again you can make first pair 1 coulomb beta 1 coulomb separation here. You can write this is 1 meter. Again beta 1 coulomb 32 coulomb beta separation beta g 2 meter and beta g you can see so on. Finally beta, this is a pair here, it's not a F net, my dear. So F net we can write beta this is F1 F2 F3 and my dear this is what you can say Fn. K into 1 beta you can say remains 1 only plus here K into beta 1 into 32 beta 2 whole square and beta so on. You can write students k into here 32 upon 2 to the 4 and so on students. K in you can take count beta 1 plus 4 8 the 32 and this is beta is so on. K beta you can write 1 cube 2 cube 3 cube beta, this is what n cube. My dear, if anywhere if you're getting this is the series kind of series 1 cube 2 cube 3 cube beta n cube, which is n into n plus 1 by 2 entire beta z whole square. So but I can keep in your mind this formula, my dear. So finally you can write here F net is equals to k into n plus 1 by 2 whole square beta, right? Here you can put here n is equals to remains beta 10. So I can write beta here result here finally. Yes, my dear. Okay. So this is f net students, k into 10 into beta 11 by 2 entire whole square is a 2 5 0 10, 5 11 here you can say 55. So f net beta g k into 55 whole square. So beta what I did here I can say this is basically my dear students Coulomb's law, right? Only Coulomb's law here. But I have one more thing here that is few questions I'm giving you as an assignment. I'll not do here, my dear. Right. But this is the first questions. Find F net following. Find F net in following figure. But this is the questions here for your assignment, my dear. But first one. But you have freedom. This is a square. Find F net at any corner. Beta this is q, this is q, this is q, this is q. Beta square side a beta. You can write f net at any corner. Beta questions number 2. Again here this is this square. Beta at center there is charge q. This is q. This is q. This is q. Now students I can say for this condition here. Again questions remain same beta. Find f net at center here which find f net at find beta f net at center beta. Question number 3rd. Now student again here this is the square. It's look like rectangle but you can read here this is q as a minus q beta this is minus q plus q plus q. Center beta there is one more charge. Find f net at center. My dear find f net at center. Beta this is the assignment here you can do. You can solve and write your answer in comment box of this video. I'll upload this video beta. You can watch anywhere here as it is. Questions remain same students. Find F net at center figure shown. So beta this is your assignment here. You can do at home. Oh beta God bless you for one. Very good. Beta. Perfect. Perfect beta. Literally here I can see in this live session you are very good and very raw candidate. Yes. You answered beta many things here. Not a single thing. Mind you, you answered many things. And those all things are literally correct. You also asked to doubt as well. So how can we do these kinds of questions? So I can say if you are very much attentive in this classroom, so just anyone can take yourself as an example in live class. In live class, literally, maybe you can perform more than that, which you are performing over here. No doubt, it's true only. Okay, so now beta further here, we can solve. There are many questions, students, so that you can do. Yes, beta. Second zero, perfect. Beta, God bless you. Second zero only. Now beta. So you can just beta do this question also here. Find f net at any corner. Find beta z f net at any corner. Not corner beta. Here I'm just telling you what you have to find. Okay. Uh, Beta, do these questions here. Find speed of particle. Find beta speed of particle. How? That's why you can say in these questions here, right? A particle of mass m carrying a charge minus q revolving around a fixed charges. Beta, this is charges here, which is plus, which is beta fixed. Another charge particle beta mass, I can say charges is minus q in beta.